This video is going to be regarding t-distributions, but we will be working with matched pairs. I have here an example problem. A random sample of 25 high school students and 27 university students is selected, and the time spent studying on a typical day as well as the time spent using social media is recorded. The data is summarized in the tables below. We have the social media, the study time, and the difference between the social media's mean and the study time's mean for the high school students, equaling 38. Same thing for the standard deviation here. And then we also have that for the university section. Now let's say we have this question down here. Conduct an appropriate hypothesis test at the 5% level of significance to determine whether there is evidence that the true mean daily study time for all high school students is less than 1 hour. This first question has nothing to do with matched pairs. This question is just going to be regarding doing hypothesis tests. We have our null hypothesis, denoted as H0, as being that the true mean is equal to 60 or equal to an hour. And our alternative hypothesis, which is what we're going to be testing, is that it is less than an hour or less than 60 minutes. We're going to be working with the high school section, and specifically the study time of the high school section. I'm just going to shrink this down and move it aside a bit. Now to solve this, we take the study time mean, the mean of the sample of 27 for the study time, which is going to be 42, subtract what we're testing, which is the 60 minutes, divided by the standard deviation of our sample, because mind you, we're doing t-distributions here. Because we do not know the population's standard deviation, notice that it is not stated in the question, and as a result we are forced to approximate it using the sample's standard deviation. Now continuing on, we're going to be using 25, the sample standard deviation, divided by the square root of our sample size. The sample size for the high school students is actually 25. We have 27 university students, so we're going to be using 25 here. This will give you a t-value. This would give you a value of negative 3.6. Now let's just hop on over to the t-table, or the t-distribution table. Now our goal here is going to be to try find the value negative 3.6 in this portion of the table right here. But notice we only have positive values. But because we're assuming the population to be normal, we can use symmetry to determine the proportion of a negative value using the proportion of the positive value. Because the probability of getting something that's less than some negative t value is going to be the same as getting the probability of getting something that's greater than the positive t value. This is due to symmetry. Therefore, we're going to be looking for positive 3.6. But we need to pay attention to the degrees of freedom. That is stated in the left column here. Degrees of freedom is calculated by doing n minus 1. Sample size, subtract 1. We have a sample size of 25, subtract 1 gives you 24. Therefore, our degrees of freedom is 24. We go back to the table, look for the 24 on the left-hand column right here. Now, this is the only row we're going to be focusing on at this point, and we're going to be looking for the value positive 3.6. The ones that come close to it are 3.745 and 3.467. These have an associated probability up here as being 0.001 and 0.0005. Because we don't have an exact answer of 3.6, we're going to be using these range of probabilities up here. We know that the probability of getting something that's greater than 3.6 as a t-value is going to be in between 0.001 and this probability right here. Now, writing it out and ordering it from least to greatest, we have the probability of 0.0005 is less than our probability for the t-value, less than positive 3.6, and that is less than 0.001. So this range is what we're going to be using for our test of significance. Now note that we are doing a 5% level of significance. This means that we're going to be using 0.05 or 5% as the significance level, and because that is the case, you must notice that the probability above is actually less than the level of significance. Because we know our probability of negative 3.6, or what we used was positive 3.6 due to symmetry, is going to be the probability of getting something that's greater than 3.6 is going to be between these two probabilities, and both of these probabilities are less than the level of significance. We can say that we have enough evidence to conclude that the null hypothesis is wrong. That means the actual study time high school students spend is less than an hour each day. And that is the answer to that question. Moving on to the next one then. The next question we have is, Conduct an appropriate hypothesis test at the 10% level of significance to determine whether there is evidence that the university students spend more time on average each day on social media than they do studying. Okay, now just like the first question, we're going to be identifying our null hypothesis and the alternative hypothesis. Now the null hypothesis is going to be that the mean difference between study time and social media, so we're going to be using this mean right here. The null hypothesis is that this is equal to 0, meaning that we are studying and using social media at the same average. Therefore, the alternative hypothesis is that the mean difference, I should put a small d down here to indicate that it's the mean difference, is that it would be greater than 0. Because notice that the difference is calculated by doing media subtract study. Therefore, if it was greater than 0, a positive number, we would be doing social media more than studying. And that is what we are testing in this question. Now to answer this question, we're going to be using the difference data here of the university section. The mean we're going to be using of the sample we got was 5. So 5 subtract the value, the null hypothesis we're testing, which is 0, divided by the sample's standard deviation, the difference between both samples standard, or rather the sample of university students' standard deviation between study time and social media, which is given as being 20. Therefore we do 20. Then we divide this by the square root of our sample size, which is 27. Notice it's a different number than the high school students. So 27. Doing this would give us a t-value we can use. It gives an approximate answer of 1.3. Now to calculate the degrees of freedom, we have 27 sample size. We have 27. We subtract it by 1. We're doing n minus 1 to get our degrees of freedom being 26. So that's what we're going to be using on the table. Jumping over to the table now, we're looking at the left column immediately to find our degrees of freedom row. We're looking for 26. Here it is. Going all the way to the left, and now we're searching for a number equal to 1.3. There is none exactly equal to it, but we do have a range. This one here and this one here. Scrolling up a bit so you can see the top row. These two numbers here are associated with probabilities 0.1 and 0.15. This is the range we would get if we wrote it out in least to greatest order. We know that our probability is in between 0.1 and 0.15, and because of that, we have to take note that we're doing a 10% level of significance. 10% is going to be 0.10. Anything that's less than this number we can consider being statistically significant. However, looking at our range, we can see that our smallest value is 0.1 and our largest value is 0.15. Both of these values are greater than or equal to 0.1, and because they are not less than it, we cannot say that our value in between is going to be statistically significant. And as such, the answer is we do not have enough evidence to suggest that the null hypothesis is wrong. Okay, this is the conclusion to this video. I hope you enjoyed it. If you have any questions, feel free to ask in the comment section below. I will do my best to answer them. And if you like this video, don't forget to press like and subscribe if you want more content like this. And I hope you are having a nice day.